We are now going to work on an example that is very interesting, and it is going to be very useful because it will allow us to understand better two interfaces that are standard. They are in the Java library and they are very commonly used, the iterator and the iterable interface. What we will do is that we will implement a solution to this problem, and then we will produce two more versions of that implementation, improving with knowledge that we will gain on the way. So let's start and see what is the problem that we want to tackle. We want to write a program that will generate the Fibonacci sequence. This is a sequence of numbers where each value is the sum of the two previous values. So, for example, in order to find the fourth Fibonacci number, we need to add the third and the second Fibonacci numbers. The first two numbers of the sequence are 1. Here is an example, as you see on your screen. The third Fibonacci number will be 2, then we will add 2 and 1 to produce the fourth Fibonacci number, so it will be 3. The next Fibonacci number will be the result of the addition of 2 plus 3, so it will be 5, and so on. We want to have in our class, in our Fibonacci class, a constructor that will take as an argument an integer, n, which will be the number of values that we want to generate. So when should we stop in the sequence? How many Fibonacci numbers do we want to produce? And this class will also have two more methods. We want to have a method hasNext and a method next. Perhaps these two methods remind you of the scanner methods hasNext and next. We have been using hasNextInt, for example, and get the next int or next double and so forth. So we want to implement two methods that will be working very similarly to what you already know from the scanner class. We will be saying, for example, while the Fibonacci has a next number, then give me that next number. Go ahead and implement the solution to this problem and come back here to work on it together. Here is the class that we have started implementing the Fibonacci generator. We have, as the problem specification asked, we have a constructor, the hasNext and the next methods. I have also written down a main so that I can show you how we want to be able to use these methods. So after we create a Fibonacci object, we're asking for to be able to produce the first 25 numbers of the Fibonacci sequence. Then we actually want to go and see these 25 numbers. So what do? We will be printing one number after the other, and we can get each of these numbers by the next method. However, we will use the hasNext method in order to know when to stop. So it will be saying hasNext as long as we are less than the 26. Again, this hasNext and next methods should be familiar to you in the way that they work because of the scanner class, and we have used it so many times. All I have done here is to actually initialize the value, the instance value of n, into the argument given to the constructor. And you may have noticed that I have named this class Fibonacci 1, and you can see here Fibonacci 2 and Fibonacci 3. We will be improving the solution, or enhancing the solution, the implementation, in further videos. But let's start from the very basics. How should we expect hasNext to be implemented? What will hasNext tell us? Well, we know n, which is all of the numbers that we want to be able to produce. hasNext should return true if we haven't yet given through next all of the n numbers of the sequence. So perhaps we should have an integer, let me call I that integer, which will be telling us how many numbers have we given back to the user of the object through next. So in other words, every time we call next, we will increase I, and we will initialize I to 0, and has next will return true if I is less than or equal to n. If we have not yet reached the end of the sequence, yes, there is a next one. Has next should be true. Great, so how can we return the next number? How do we produce the next number? We said that in order to find the next number in the Fibonacci sequence, we need to add the previous two Fibonacci numbers. So perhaps we should keep track of the previous two Fibonacci numbers. Maybe we will call them F1 and F2. So these should be the previous two numbers of the of the sequence that we want to return next. So at the very beginning, F1 and F2, the very first two numbers of the Fibonacci sequence, are 1. And again, this is just a mathematical property, the way that the Fibonacci sequence is defined. We are not taking any special freedom here. So when we want to return the next number, or we would like to do, would be to return F1 plus F2, right? We just returned the sum of these two numbers, which means that this should also come before the return statement, otherwise it will be unreachable. We will not do I++. And why do we want I++? Because again, it is needed for the implementation of has next. We want to be able to return as many numbers as defined by n. Now, here is a trick with the next though. We need to be updating also F1 and F2, not only I. As soon as we return the next number in the Fibonacci sequence, then when we want to call next again, F1 and F2 will not have the correct values, right? So think of the first time we call next. Next will return the third number in the Fibonacci sequence, F3, right? Now, the next time we call again this method, we would like it to return the fourth number in the Fibonacci sequence. So F1 and F2 should be different. How can we do that? We need to update the values of those inside F1 and F2. Even if you have not yet implemented the solution to the Fibonacci numbers, maybe you pause the video here and try to implement the next method. I have inserted inside next a few statements that will actually update the values of F1 and F2. So F2, the new F2, will have to be the number that we are now returning from next. So that the next time we call the method, F2 is the previous number of the Fibonacci sequence. So here it is, we are adding the current F1 and F2 and taking this value and making it the new F2 value. As for F1, it will just take the value of the old F2. And we will return T, the currently next number. Now, if we run this code, and let me just do it, and of course, here we are printing the first 25 numbers of the Fibonacci sequence. You may want to start experimenting with something smaller that it is easier to check. You will see two problems. One is that it prints 26 numbers instead of 25. And the second is that the very first two values are never printed. So next will not print the first two numbers of the Fibonacci sequence. And if you see the implementation here, it is very reasonable. What we actually want is, because the first two numbers are not produced in the same way as the others, they are not the sum of the two previous ones, we want to add this if statement that if we want the first two numbers, they are always going to be 1, no need to bother with addition. Now if we run it again, you will see that it will print the first two numbers. Now the fact that it prints 26 numbers instead of the 25 that we wanted to generate it has to do with the fact that here we say I is less than or equal n, but we initialize I to 0. and not to 1. So we should either have I equal to 1 and keep it as it is, or I equal to 0 and then make this strictly less than. This is the very common mistake that we can also do with a for loop, if you remember. The value that we start and then the condition that we check. So now if we run our code, it should be having no problems. It will both print the first two numbers of the Fibonacci sequence, which are both 1, and it will also only print 25 numbers instead of 26 as before.